Okay, so here's a harder example of a system of equations that we want to solve through graphing. So the first step is I'm going to come over here and I'm going to build an XY table, and let's make these a bit smaller. So here are my two equations. Now the reason why this one is a little bit more difficult is because I have these equations and you can see that they're two separate equations. They're both not in slope-intercept form. So slope-intercept form is where we have the y's by themselves or isolated. So the first step here, which we didn't have on our other problem, is we are going to put both of these in slope-intercept form. And remember, you guys know slope-intercept form as y is equal to mx plus b form. So let's do that before we move on for both of these equations. So let's do this one with scaffolding, and we'll do this one without scaffolding, meaning I'm going to write in all my steps here. So I want to get y on the left hand side, so I'm going to add 3y to both sides. That brings me to 3y plus 2x is equal to negative 6. Alright, now I want to get the x over here, so I'm going to subtract 2x from both sides. And that gives me 3y is equal to negative 2x minus 6. And just so there's no confusion, that's an equal sign. Now I'm going to divide everything by negative 3. And when I divide everything, I divide every single term in here by 3. So that gives me y is equal to negative 2/3 x. Negative 6 divided by 3 becomes negative 2. Alright, so this is the red we're calling the scaffolding. We're putting all of our steps in there. Let's do this side and let's see if we can do this without writing in all these steps, all the red. We'll do the steps in our head and we'll write each new line down, the ones that are in black here, without the red. Alright, so in this step I am subtracting. I want to get the 42 to this side, so I'm going to do that step in my head. Subtract 42 from both sides. So I know that that term comes over here, and now it's a negative. Now I'm going to divide everything by negative 6. So when I divide negative 5 by negative 6, the two negatives cancel out, so I get 5, 6x. And I have negative 42 divided by negative 6. Well, two negatives again cancel out, makes positive. And 42 divided by 6 is 7. So you can see that this way is much cleaner than this way. So if you can work your way to this, that's what your goal is. But if you still need to write these steps in, that's fine as well. Okay, so we have this equation, and we have this equation. So here's our two equations. So I'm going to get rid of all of this. Just put, there's our first equation, and here's our second equation. Let's see if I can change this to a different color so that we can differentiate these. Alright, here's our two graphs. Now remember, we can graph multiple ways. A way that always works is creating a table and picking values and solving for the dependent variable. But let's use slope-intercept, since these are in slope-intercept form. Let's graph this equation. So since I have my y-intercept is negative 2, so my y-intercept is negative 2, I'm going to come down here and graph my y-intercept at negative 2. Alright, now my slope is I rise a negative 2 and I run a positive 3. So let's do that. So here's my rise a negative 1, 2, and run positive 3, 1, 2, 3. That puts me down here. Now note that I wouldn't be able to see my next step, so that's equivalent to rising a positive 2 and running a negative 3. It still falls along the line. So here's the black line. A little off there. Fix that. Now let's do the blue. So this blue line, I have a positive 7 for my y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And I'm going to rise 5 and run 6. Well, if I rise 5, that puts me off of where I can see. So let's do this. We know that two negatives equal positive. So let's rise a negative 5, negative 1, 2, 3, 4, 5, and run a negative 6, negative 1, 2, 3, 4, 5, 6. And let's plot that right there. Okay, now let's graph this. Alright, now if you look at where the intersection is, if we look at this, here's my intersection point, and it looks like we're a little bit off here. So it looks like they intersect right here, not at an even integer. But what we're going to do is it's probably because we didn't graph exactly. So this is a good learning, teachable moment. So let's pick the point that's closest here. So this looks like it's negative 1, 2, 3, 4, 5, 6. So my x is negative 6, and my y is 1, 2. And let's substitute this value into each one of these equations and see if it works out. So now we're on the last step of checking. So let's see. If y is 2, well, let's try negative 2 thirds times my x is negative 6 minus 2. So that gives me 2 is equal to, well, 3 into negative 6 goes negative 2 times. So we have negative 2 times negative 2 minus 2. That's positive 4, so that's 2 is equal to 4 minus 2, which that checks out. 2 is equal to 2. So we get a big check. Alright, let's try this one now. If we have, well, again, my y is 2 is equal to, we'll go back to using 5, 6. So 5, 6 times negative 6 plus 7. So the 6's cancel out, and I have negative 5 plus 7. That is equal to 2. So I get 2 is equal to 2. Both of those check out. So my answer, my solution, is negative 6 and 2.